right? And we're live. So I think for this session, it's probably going to be very short. I don't have too many updates. It's been busy. I don't know if you got anything, Mohammed. And Frans? Frans is here. Maybe it's going to be a long meeting after all.
That's a good introduction to me. Thank you. Good evening.
You're so welcome. I
Is
only
this
mean it.
being recorded already or?
Yes, we're on.
Okay.
It's live.
Okay.
And I only mean it in the best possible positive way, right? Because we have
Yeah, I know.
wonderful
Yeah.
discussions.
Indeed.
Yeah, so as I was saying, with regards to topics, I don't have too many topics for today, unless somebody has something they would like to discuss. That's perfectly fine. And maybe while you think about it, I will just jump right in and talk about my little update, which is as follows. Just to recap from last week, I showed some updates with regards to the workflow designer. I mean, actually create a new one. And if I recall correctly, it had something to do with composition. So you could compose workflows. This is not a good one like this. And you can drill into the activities that expose activity type properties like for each, like if with, and then you can configure what you want to execute in the then branch or in the else branch if the condition is false. So straightforward. I think a couple of meetings ago we also talked about flowchart style activities, right? Because these are called sequential, if you will. They're composable, but if you have a typical flowchart style diagram, then you will want to be able to draw lines between activities, like between the right line and then the if in this example. And instead of drilling into the if activity, maybe you just want a true and a false outcome, and then you can connect a true or and a false outcome. So I think we want both kinds of activities so that you can wrap nested flowcharts within an activity. And in other scenarios, you want to orchestrate it using more of a flowchart style. So for that, we have that's what I've been working on the past week, is we have now a new category called flow. That includes a flowchart, which we've been looking at the entire time, because this canvas is a flowchart activity. But now you can also drag them onto the canvas, and now it acts like a container. So you can have many sub flowcharts if you want. So you can click on edit and then start creating subflows. And then it can of course be nested. And then here there's a little breadcrumb trail, so you can navigate up the hierarchy. But that's not the only thing I've been working on. I've been working on the flow decision, which is in Elsa 2, this is the if activity. And in Elsa 3, the if activity is this style of activity with the then and else activities. But if you want the flowchart style decision activity, then you use the flow decision. And this allows you to, of course, specify a condition here, for example, true, which results always true, of course. And then you can connect either this one, or if the outcome is false, connect to another activity. I want to do this also for the switch activity. So let me clean up this mess for a second. So the switch activity is similar to the for each and if with regards to it being a sequential activity. So it means that for each of its case, you drill into the activity and this define the inner flowchart from a nested designer. So let me first show you what that looks. So let's build out a few cases. Case 1, 2, and 3. The X variable doesn't exist. This is just for demo purposes. So here, as you can see, for each case, we have, these cases displayed on the activity in the designer. You can't currently drill into it. Well, you can, but it's not actually going to be persisted because I'm still working on that. But you get the point, right? So this is a different way of composing your workflow. But this may not be what you want for certain scenarios. Instead, you will want each case to be an outcome of the activity. So for that, there will be a flow switch that would look similar to the flow decision. So instead of true and false, you would have case 1, 2, and 3 as outcomes.
But when you added the cases, it showed them already, like this. Did you see that?
Yeah,
So
you mean these things?
No, but if you can you add a new switch to the canvas? Because I have a question regarding that. But if you add new cases to this,
Like this?
you see, yeah, another one. Now you have case 1 and 2 also as flow points at the end.
Oh yeah, yeah. Don't mind this. This is a bug.
Oh, I don't find it's a bug. I find this quite interesting because I was
Sure.
wondering about the if and the flow decision. Basically, in the implementation or the JSON representation of this, there will not be a difference if you do the flow decision and the if, basically.
There actually will be a difference in the JSON.
Okay.
When using the flow decision, the connection between the true outcome and some next activity, and of course the connection between false and some activity, will be stored in the JSON document as a connection object. And it will have as a source activity ID, the flow decision, and as a target, in this example, the if, and the name of the outcome, in this case, false. So that will be stored in that manner. But when you use the if activity here, the property of then will actually be stored as a field on the if element. Yeah, so it will be represented differently as well. And I can actually show you in the, well, I can try and explain it through the object model. So here we see if. So if you would for a second imagine this if class being serialized into JSON, you can see that it has a then property and an else property, and they are of type I activity. So these would actually hold objects in them. So this would actually be something like, I don't know, maybe a right line. Yeah. So so it is different, and it will only work. These kind of activities will only function properly within the context of a flowchart. So the flowchart is the activity that knows about flow decision.
Yeah, because I was wondering if we could use an endpoint on just on the then and else on that little square in the middle with the plus, that you would have a blue dot there and connect it from there. That you don't have that difference in the flow decision and having to think, well, why do I need a flow decision or an if?
Yeah, I was thinking the same, but I wasn't sure how that would be done elegantly, because what would it take in the backend to have these two notions? So one way could be to do it what I was originally attempting to do, which is with the transposition or the transforming, right? So a couple of meetings ago, I tried to explain what would happen if you connect, and not this one, but like this. So what I would do before sending this to the backend, I would basically take this activity and store it as a property on the flow, or on the if activity, and then but visually it would be different. But there's this, it's a different representation. We talked about maybe it makes more sense for the designer to also reflect the actual composition the same way Windows Workflow Foundation 4 does. Speaking of which, they too have two different categories. One is the sequential set of activities, like if, or they probably call it something else, but it works similarly. And then they have flow nodes, and those flow nodes only apply to flowchart activities.
So
I think both types of activities are useful, and there are use cases to choose one over the other. I think the good thing now is that we don't have a done outcome from the full flow decision. So at least in this way, it is more logical that we only have true and false outcomes. So that will help us maintain the flow chart type of kind of flow.
Yeah, and that's a very good point, because in Elsa 2, a big issue, I think, is the fact that the if activity does have three outcomes: true, false, and done. And done will always be executed, but only after either the true or the false branch is complete. But it's a kind of a weird thing, because it tries to model composition in a way, but which allows the user to make weird connections, for example, for each loop, for example, back onto some arbitrary node in the, or activity in the flowchart, where it wouldn't make sense because that target activity might live on an entirely different level. This hierarchy of activities, it's not visually represented in that way, so it could lead to very strange results.
Yeah,
agree. It's a fair point that done was indeed a bit confusing at times. So this is quite nice. I'm really interested in the use cases where you opt for flow decision or composite if less, when you would opt for one or the other.
Yeah.
I'm not
There are
really
use
sure
cases.
what.
So there are use cases. I will try to think of an example. Nothing comes to mind right now, but I've worked on workflows for a customer where sometimes in the same workflow, if activity should only have a true and a false outcome, or only one of those, or only those two would be used, and the done would be ignored. But in many parts of that same workflow, the done outcome was actually used. So we wanted to have actually this if activity with the then and else, and then the done outcome. This is basically the done thing here, but it's modeled in a different way in this workflow for good reasons. Because here, to me at least, this logically means when this activity executes or evaluates its Boolean condition, then the then or the else branch will execute. And no matter how complicated or how long running the nested activities are, at some point it will finish, presumably. And when it does, then it will continue on to the next node here. So this more closely reflects that what I wanted instead of the workflow for this customer I'm mentioning, where I would have to follow the then branch and the else branch and then back to the done branch. And theoretically, I could even connect somewhere from the true branch all the way to this activity here, which would be weird. So long story short, there are use cases, but let me try and come up with a few good examples.
Yeah, I think your explanation is quite clear already. If you look at the flow decision, then you have the true and false, and you can basically get the same result by joining the true and false execution lines at some point again together. And then you would have the same as the if implementation right now. But then you have to think about, okay, what are my endpoints in those flows? And you have to all join them and then join them with one off. And this makes it really more clean if you want to have the execution of then either else and then continue. So yeah, for me it's clear that they serve their own rights in the implementation of workflows.
Great. Yeah, for sure. So this is an example of merging back into this branch here. Of course, this is not a fork. This is either true or false, and then no matter which one executes, here it continues with the switch in this example. And if you have many sub branches, then you would potentially have to connect it back to the switch if you have multiple activities here. Could even be other decisions and switches. Yeah, exactly. Yeah. Yeah, it works. Too, it completely depends on what you're implementing, I guess.
Yeah. Okay.
Yeah, so that's what I've been working on. In terms of API, maybe it's interesting to take a quick look at that as well. How would you implement it as an activity developer? I mentioned that the Flowchart activity knows about the if or the flow decision, but that's not entirely accurate. The way it works instead is as follows. And let me show the Flowchart activity first. All right, just taking a second to remember what I did here. Oh yeah, okay. So what the Flowchart activity actually does, it has a function that is invoked whenever a child or a descendant activity completes. So these could be activities that are not scheduled by this activity itself, in which case it will be ignored. So it's going to see if the completed activity was scheduled by this activity. So if it's a direct child, then it continues. If not, it exits. If it is a direct child, then it's going to check for the completed signal to see if its result is of type outcome. And this outcome is a class that lives in the domain of the flowchart. So only flow nodes are aware of the outcome class, and if those flow nodes complete, they will complete by setting a result of type outcome. And the outcome class has a bunch of just one property, just the name of the outcome. So let's take a look at the flow decision activity for a second. So this is a very simple one. It will have its condition evaluated when set, although I'm probably going to change this so that the activity itself will evaluate the condition here. A little sidebar there. The reason for that would be to allow the activity to execute multiple times, because there are some scenarios, I am blanking on what those scenarios are, but where you want to re-evaluate the condition. I think it might be in a loop, or so there was some scenario. I will get back to that. But anyway, when this is evaluated, it's going to set an outcome to true or false, and use that result when completing the activity async. So here, this activity is explicitly completing itself. So this is a new concept in Elsa 3, where activities, they need to signal to the system that they are completed, because there may be activities that will start, but they will not complete until some condition occurs. This could be waiting for a signal, could be waiting for user interaction, or even just waiting for its children to complete. At some point it will complete. In this case, this will complete immediately, and then we yield back control to the flowchart activity, and it will check for its outcome, and then depending on the outcome name, it will find the next connection to schedule. So that's what it's doing here. It's finding the connection to schedule next. So this would be an activity connected to the true branch or the false branch. For activities that are not aware of the flowchart activity, they will not even use the outcome. So by default, that connection will be using the, well, quote, done outcome, but that doesn't really exist in the from the point of view from regular activities like finish, for example. It just completes through this is a bad example, the readline activity. It inherits from activity, which completes by default once execute finishes, but it doesn't schedule or tell the system that it's completed using the done outcome or anything. So that's just a default thing, which in my mind makes it more flexible compared to the flow chart activity in Windows Workflow 4, because there, if you create a flow chart activity, the only types of activities you can add to the service are flow nodes activities, if I'm not mistaken, but that's what I think I remember of that. In contrast to Elsa 3, you can add anything to the flowchart, and certain activities, they are aware of the flowchart, so they allow you to provide additional outcomes other than just the done outcome that we see here.
I have one question about ports. So do you allow multiple connections from the same port as an outcome? So for example, out of the true, can you connect to multiple activities, or it will be only limited to one?
Yeah, it's undecided really at this point. I don't know what I did. I broke something here. Anyway, let me do a new one. So good question. I think we talked about this a couple of meetings ago.
Yeah.
And I think the jury is still out. So right now you are able to do it. The designer does not prevent you from doing this. And it will this will work. So this will cause both write lines to execute. But it also means that this write line here will execute twice. So what will happen is both activities will execute, and then because those two connections will be scheduled as well, this write line will execute twice as well. And from a user's point of view, this is probably not what you expect. What you probably expect is this one to execute, and then this one to execute just once.
Yeah, we discussed this about the implicit fork and join.
Right.
Whether we want to make it implicit or explicit. So that is.
Yeah, exactly. So I haven't decided yet. If anyone has any good suggestions on this topic, I'm all open for it, of course. So one option would be to introduce a fork and a join activity, and then disallowing these multiple connections being drawn out of this outcome here, and then also having an explicit join to merge back executions. That would be the simplest approach, but it also adds more noise to the workflow, right? Because instead of just having these four activities, you would now also have a fork and a join, so that would be two additional activities. The good thing about that is...
Yeah, we talked about that, that we could have, when you have multiple inputs, that you could have an extension on the properties, that you could say there, wait any or wait all.
Exactly.
And it wouldn't add it to the workflow. But I'm also not sure about what to choose here. And you want to have that flexibility, I guess, but you don't want to have the feeling that something magical is happening when you're not aware of this situation, that you can have multiple tokens running in the same workflow, and then basically splitting the work in parallel and having things executed twice. That's not what you expect.
Because looking at the code that you are showing right now, I think you are scheduling one child at a time.
That's right. Yeah. So when this completes, the flowchart activity will see there are two connections, so it's gonna schedule both connections. So that's this code here. So as you can see, it's getting all the connections that match this query, and this query is about getting all the outbound connections. So this one completes, so it's seeing this one is a connection and this one is a connection, because they both have this source where the source is the completed activity. And then of course, if we change this to first or default, it will only execute either this one or this one, but that's not expected either. You would
Yes.
expect both to execute, but then here you somehow expect this to be executed once. But logically, to me, it makes perfect sense that this would be executed twice. But I can see from a user's point of view that it will be unexpected.
My current feeling is that to disallow the multiple connections and have the explicit fork and join, but maybe that will complicate stuff.
Yeah, maybe. I'm
Yeah.
tempted to go with that as well because that will keep things simple if we disallow multiple connections and then just introduce fork and join, which would make things very explicit. But before making a final decision, I would suggest let's take a look at some of the other engines out there like N8N. I think that's the correct term. Powerful workflow automation tool. And I believe they too allow, as you can see here, multiple outcomes. So I'm just very curious to see what would be the behavior if you would then connect this one to the if here, and would if then execute twice or not. So let's see what tools like N8N do in this scenario.
But normally when you do this, I think you are expecting things to execute in parallel. So in this example, you are passing the data to Google Sheets and at the same time you are writing it to database. So it's two things that you want to do. Yeah, I don't know. It's not that sequentially you expect to execute one by one. It's something that you want to do it in parallel and then maybe it doesn't merge it. I don't know really.
Yeah, maybe. So this, of course, this is executes in parallel. Although, is it really in parallel, or is it gonna schedule one by one and making it seem like it executes in parallel? As far as I know, most workflows make it seem like it executes in parallel, but doesn't really. But even so, even if this is a true parallelized execution, would you also expect if to be executed twice? So maybe it doesn't matter whether this is truly parallel or not. Logically or functionally, it is in parallel.
Yeah.
So yeah, so that's what I think we should do. Is take a look at this one and maybe one more and see what solution they offer and learn from them.
Yeah. I think it depends on the type of the workflow. If it is a kind of a data processing pipeline, then you really don't want things to execute multiple times because then the outcome will not be desirable.
But in that case, how do you determine? And somehow they would know that both should be executed, but somehow this one should only be executed once. Then how would they know? Because there may also be inbound connections, like from some other source brands, and then in that case you do want the if activity to be executed. So so we will see what we come up with.
Maybe we can do something in the UI then. That when you see that you have multiple lines there, that you can either right click and say like wait any or wait all, that it doesn't clutter the workflow, but still be present there.
Yeah, and then the default should be wait. Well, wait any is also not going to work because what you don't want to happen is this activity executing and then continuing while this one will then execute next and then somehow, well, let me just put it this way. In Elsa 2, the way the join works is as follows. Whenever an inbound activity completes and executes, then the join activity executes. And what it does, it checks to see what was the inbound activity or the connection and what activity connected to it, and then it's going to record the ID of the activity that executed before, and then depending on the join mode, it will either continue or it will wait. So if you say wait all, it will wait. It will not yield to the workflow runner, so it's not blocking either. It's just gonna it's gonna cause the next activity not to be scheduled. So whatever comes next, and then of course this one executes, will be recorded, and at that point the internal collection will contain all of the activity IDs of corresponding to the inbound connections, and then it will execute. But if let's now say we don't have a join activity, we have just a write line activity, which itself doesn't have any logic regarding joins, so it needs to be somehow implemented by the flowchart activity. Yeah, I'm just wondering how that would work nicely. Yeah, I don't know. I need to give it some more thought.
Yeah, it's a tricky one. Discussing all these things, I think the explicit fork and join makes it really clear about how it works. But indeed, it clutters. But for me, knowing now all those scenarios, I don't see that you can avoid that.
Yeah.
So tricky because, like you said, do you expect them to be run in parallel and not continue? If you have a fork and join, then it's really explicit. Well, it runs in its separate synchronization and it doesn't synchronize with all the first activities of any fork and do that first and then the second one until it's reached the join. In this case, you expect that actually to happen, and that makes no sense from the point of view of execution or workflow.
Yeah, that's well put.
Yeah.
Yeah. So yeah, I'm leaning towards that solution, but I want to see what the way it behaves in this flowchart here, because if let's say we connect Postgres to if and it turns out that if is executed twice, then to me that's confirmation that it is a logical effect, which to me also would mean maybe we should not disallow splitting the workflow like this. But if you want control over merging, then we need the join activity and the fork activity, because otherwise it's maybe we need the fork activity, maybe we only need the join activity to properly merge into a single activity so that you can control the behavior. Because maybe in some scenarios it's okay for this to be executed twice. Other scenarios you don't want that to happen, and then you need some mechanism to control that, and that could be done through the join activity.
Because the current execution of what you said is they just select everything that comes out of the write line in this case, and they are both scheduled, right?
Yeah, that's right.
Does it first execute the full first one?
That's right. Yeah. So the way it happens, it goes in, and then let's say this one is the first connection it finds. So it's going to schedule this one. And if this one is, let's say, or maybe the next one is an HTTP endpoint, let's say this. So this is a blocking activity. It's not going to schedule this one. It's going to be waiting here.
Oh, gee.
Yeah.
Yeah, that's the question I wanted to ask. Like, put a read line there. When does the other one get scheduled then?
Yeah, this one doesn't get scheduled until this one completes, and then this one executes, and then it's the end of there are no more activities in this branch. That means the flowchart activity, the outer one, will now look at the next connection, and that will be scheduled. Or actually, this will already have been scheduled, but it will only execute once this one is done, and then this one will get its turn. There's of course a way
Would it be
to.
different? But would it be different if you would have the fork activity in between? Or
No,
is that actually the same?
it's the same. That's also how it works.
Oi.
Really? So fork will not make it parallel?
Nope. It will go from the first branch to the second to the third, etc. Yeah. And then only once the first branch completes, then it will go on to the next one and the next one, etc.
But how then in Elsa 2? In Elsa 2, when we have like a blocking activity signal, it feels like it's executing parallel, right?
Oh yeah, so indeed. So let me clarify for Elsa 2. If as soon as it hits a blocking activity, then the second branch will be executed and the third until they either hit a blocking activity or a join activity. Yeah. So there in most scenarios it works fine, because typically you use a fork and a join where you want to be waiting for some timeout to occur, let's say a day, to give some user some time to approve a document or so, and then either the timeout occurs or some user approves or rejects some document, let's say. So for those scenarios that works out fine. But it can be a problem if you have multiple branches and you expect all of them to execute, but if there's a blocking one here, as the case is here, then in this Elsa 3 engine it will be waiting for this forever. It will not go ahead and schedule this one. As it is right now, I do have some ideas on changing this, because even in Elsa 2 it can be a problem where the other branches don't get a chance to execute. And I think I wrote a little issue for this one, a proposal for parallel processing of branches. And the idea is that the inner loop that reads off the stack of scheduled activities, instead of doing it one after the other, it would be a multi-track stack. And then what I mean by that is it would be basically alternating between logical tracks. scheduled on this stack. So it would first schedule activity 1 from track 1, and then no matter if how many more activities are on track 1, it would then switch to track 2 and schedule its activity, and then switch to the next track, and then back onto the first one. And a track in this example would correspond to a branch. So if there's 3 branches in a fork, or in this case 2 branches here just coming out of right line, there will be 2 tracks, and both would execute one after the other, and then this one would execute, and then this one would execute coming from this one. And here it would be blocking, and once this resumes, it would execute this one more time.
Okay. Which number was it? 2878, right? For the issue.
Oh, this one, yeah, 2872.
72. Okay, take a look at that and think about that.
Right?
Because it's a really tricky one. I didn't see that one coming.
That happens to me all the time when I work on these things. It's like, oh wait, didn't see that one coming.
Yeah.
Because many scenarios, works on, I would say, on that illusion now that we are parallelly executing the branches in the fork.
Yeah. Yeah, of course, it's what it looks like, so it makes sense.
Yeah.
You would expect it, but nothing could be further from the truth.
Wow.
But imagine if you are looking at a data processing scenario, you are writing the data to a database, same time you are sending it to another system, like the same image that for Google Sheets, right? So if I'm really waiting for one of the branches to finish, then I will start the other. It's a big hit.
Yeah.
Oh yeah. Yeah, and this is something I want to have available in Elsa 3 is a parallel branch that truly executes in parallel. But it's going to be interesting to figure out how to deal with, the container or the application instance going out of memory or crashing.
Because one scenario I'm going to start looking at soon is this MQTT scenario, where I'm continuously receiving data from like my edge device, and definitely I need to process it into multiple streams. I need to store it somewhere. I need to build some logic, generate some alarms, all these kinds of things. So it's a truly parallel idea.
Yeah, makes sense. Yeah, and this is what we should want for Elsa 3 as well, to be able to act as a data processing pipeline similar to Azure Data Fabric. Have you guys heard of that? I think it was you, Ahmed, who came with...
Yes. I built a similar scenario in DF, which is for MQTT. I'm getting the data from an edge device. I processed it through Stream Analytics, and then from there I took it to Azure Data Factory. So I want to make the same thing in Elsa. This is my target soon.
That's beautiful. Nice. Is there a reason for you to use Elsa instead of Data Factory in that for that scenario?
We want to build it around Elsa because we want to as a central part for the engine.
Right.
We want to make it available there. Azure Data Fabric, then you are linked with the service from Microsoft Azure, right?
I think so. Yeah. Because this one probably does this one support parallel? Do you know if this has parallel executing activities like parallel loops or?
Yeah, you can put the activity and then you can branch to the other activities. So if you put multiple activities and then you can connect them, it will support.
Sure, but I mean, let's say I have this switch and I have a couple of cases.
Yeah.
I don't know, maybe append a variable. Hey, how do I add a new case? Do you know? Maybe from here. Okay, here.
Yeah.
So let's have 2 cases. Okay, and each case is embedded, let's say. So do you know if these cases are executed? Oh, it doesn't make sense, right? It evaluates a property on the switch and then eats one of them. Yeah, this is
one of them. Yeah. But if after the switch, if you have 2 activities, you can branch to both. It will allow you, and they will both execute.
Oh, and in parallel, you mean?
Yes.
Okay, like this.
Yeah.
And what happens if I now say read and I go from this one to this one? What happens now?
I don't know.
Okay. Let me know when you figure this one out. This would be a good one to understand as well, and we can compare it to N8N.
But I would assume it will execute once, because maybe they are keeping like a tracking if the activity is executed or not. Because here you cannot make a loop. You cannot. It's limited in that sense. It's a sequence, right? It's a sequential execution.
So I imagine this one executes first, then this one.
Yeah, these 2 in parallel, maybe. Then last one.
Oh, this one in parallel, and then let me know, man. I'm really curious to to understand this.
Sure.
Thank you. So yeah, parallel executing would be a thing to have, and maybe even on this chart as well. Maybe, I don't know. It seems very complicated. All right, that's all I had for today. Does anyone have anything else?
No, I have my homework cut out again, so I'm gonna think about this one.
Perfect. Okay, then in that case, I'll see you guys next week.
Sure.
Yeah. Thank you again.
Thank you for joining.
Thank you.
Okay.
Nice.
Nice evening. Bye bye.
Bye bye.